The design guidelines for the chain drive. When we design a chain drive, we should start with some assumptions. For example, that the minimum number of teeth should be 17, unless operating at low speed, like for example, less than 10.5 radians per second. The other assumption is that the maximum speed ratio to be 7. The center distance between the sprockets axes should be approximately 30 to 50 pitches or 30 to 50 times the pitch of the chain. The larger sprocket normally has no more than 120 teeth. The preferred arrangement for the chain drive is with the center line of the sprockets horizontal and with the tight sides on the top. Chain length and center distance can be calculated using the equations 718 and 719. As of the build drive, the chain drive can be selected from the data tables. Pitch diameter of sprockets with n teeth for a chain with a pitch value of p can be calculated by using the equation 720. The minimum sprocket diameter and the minimum number of the teeth in this sprocket are limited by the size of the shaft. The arc of contact in the chain is equivalent to what we call the wrap angle in the case of the belts and pulleys. For the smaller sprocket, it should be greater than 120 degrees, and the angle can be calculated by using the equation 721. For the larger sprocket, the theta 2 can be calculated by using the equation 722. Other design assumptions we have for the roller chain are the number of the teeth on the sprockets, where the smaller number of the teeth, the greater the shock loading is. The chain speed, where the greater the chain speed is, the greater the shock loading will be. The poor lubrication will shorten the life of the roller due to the wear. And the dirty or the dusty condition will tend to have an adverse effects on the roller chain life. In this week's tutorial, we are going to cover 3 examples. For the first one, we have been given the following parameters. First, the driver is going to be a gasoline engine. Driven is a heavily loaded coal conveyor. The NI value is going to be 94.23 radians per second with the power of 11.18 kilowatt. While on the exit side, we are going to have the RPM value, or the omega, is going to be 24.08 up to 25.13 radians per second as the limits. We need to find the design of the chain drive. On the second example, we need to specify the required length of the number 60 chain to mount the sprockets having 15 and 50 teeth with a center distance of no more than 914.4 millimeters, and compute the actual center distance. And example number 3 is going to be determine the power rating of a number 60 chain single strand operating on a 22 sprocket and 750 RPM. Describe the preferred method of lubrication. The chain connects a hydraulic drive with a meat grinder. What will be the rating for the 3 strands?